All right, we're in AP Stat. We're in Chapter 7. And again, I'm just kind of going over some practice problems, mainly with scatterplots to make sure that we understand the background, how they all work. And as this says, like the association, the correlation between them, and just to see how everything connects. We went over an overview already. We went over some just a summary of just Chapter 7 notes as well. Let's focus on some problems now. Again, very well might be moving very, very fast. And as I'm moving fast through these, remember, you can always pause these videos, write the problems down, and continue on your own. So, suppose you were to collect data for each pair of variables, right? And you want to make a scatter plot. Which variable would you use as the explanatory variable and which as the response variable, and why? And what would you expect to see in the scatter plot, and discuss the likelihoods. So for example, what's it formed? Is it positive? Is it negative? How strong of a correlation is it? But anyway, so you're looking at apples, and you're looking at the weight in grams and the weight in ounces. All right, and you're comparing which one is the explanatory and which one is the response. Here, circumference versus in inches versus weight. C, college freshmen, their shoe size and their grade point average. All right, gasoline, number of miles you drove since filling up, and gallons remaining in the tank. So take a look here. For the first one, point is sometimes people have a hard time deciding which one do I make the explanatory. Explanatory as in the X, response being the Y, and it says either weight in grams or weight in ounces could be explanatory or response. This is just an example where sometimes it's hard to decipher which one. It's not really going to matter impact-wise. It says greater weights in grams correspond with greater weights in ounces because technically speaking, they're both weights, right? So if something weighs 1 gram and the next thing weighs 8 grams, it's going up, right? Well, if something weighs, what was the other one? Ounces, like 16 ounces, and then it weighs like 48 ounces, it's still going up because it's in correlation. It's just change of units is the point. So the association between the weight of apples in grams and weight of apples in ounces would just be positive because basically it doesn't matter. In grams, right, versus ounces, it's the same weight just on either axis, right? The association between them, it would be positive straight, and it would actually be perfect because there's a conversion. You would just convert one into the other. Each apple's weight would simply be measured in 2 different scales. The point would just be a straight line, more than likely, right? It's this many grams versus this many ounces, and as the apple gets bigger, gram-wise, it should also get bigger weight-wise with a straight-up conversion. With part B, circumference is the explanatory variable and weight is the response, since one-dimensional circumferences explains 3-dimensional volume. All right, so what we're getting at is trying to think of formulas. You're talking about the weight of something. You're talking about the volume of something, right? So the idea here is, how do I know which one is which? The point is, if you're trying to figure out which one is which, inside the volume of something, right? Even if you're thinking in terms of just like, even though it's an apple, think about it in terms of circles, right? The circumference formula itself is technically inside of a volume. You can't find the volume without technically knowing that part, the circumference-ish. That part of the formula is in it, which means it's like you're plugging it in the X. So that's why the circumference is the explanatory variable, and the weight is the response, and you would assume the larger the circumference, the more it would weigh, right? The larger the circumference, the more it would weigh. So for apples of roughly the same size, the association would be positive because the larger they are, circumference-wise, more than likely the heavier they are, right? And it would be probably pretty straight, right? And pretty strong, but necessarily, depending on the specific weights, it's not going to be a perfect line because it's not a direct conversion from one to the other. If the sample of apples contained very small and very large apples, the association's true curve form would become apparent. In part C, The problem is there is really no association. It doesn't matter what their shoe size is. That's not going to affect the grade point average. So there would be no association. I mean, you could plug it in, but there wouldn't be anything. As in, like, it wouldn't matter where you put X and where you put Y. Like, I could make X be shoe size, sure, but the grade point average of that person with the shoe size could be all over the place, so it wouldn't matter. I could make grade point average be here, but the same thing. Your grade point average has nothing to do with that, so there's no association. Therefore, it wouldn't be straight, it wouldn't be linear, so it wouldn't really matter. And then in part D, it says number of miles you drove since fill up and gallons remaining in tank. So think about this in terms of a car in general. How many miles you drove since you filled up means your tank's probably getting lower anyway, naturally, right? So my point is, it should probably be going down as the number of miles you drove since fill up keeps increasing. The gallons left in your tank should be decreasing. So more than likely, this is what you're putting in because you put gas in, right? So the number of miles driven is probably the explanatory, and the gallons in the tank is the response variable. The greater the number of miles driven, the less gasoline there is in the tank. If a sample of different cars is used, the association is negative, straight, and moderate. So it's negative, it's straight, and it's moderate. Now, we don't know the exacts of how in-depth it possibly is either. All right, taking a look at this one. Suppose you were to collect data for each pair of variables. You want to make a scatter plot. Which variable would be the explanatory and which would be the response? It's basically the same type of question that we did before. Now they're saying t-shirts at a store, right? The price of each and the number sold. So this kind of depends. As the price goes up, if we use price as explanatory, let's just say that we did. As the price increases, it depends on how good the shirt is. Technically, it could be all over the place, but the assumption is as the price goes up, the amount of shirts is probably going to go down, like the quantity will go down. If I have $1 for the shirt, there's a more likelihood that it'll be way up here, like, oh yeah, sure, we'll buy that. But if I wanted to charge $1,000 for a shirt, I'd probably get barely anyone to buy it. Scuba diving. The depth and the water pressure is another one where it's probably, well, the depth is probably your explanatory, and we'll see. But the farther down we go into the water, right, the farther down we go into the water, there's normally more pressure, which means it's going up. So the farther we go this way, as in the farther down we go, the water pressure goes up. So it might be a positive correlation depending on how we have it. Scuba diving depth versus visibility, the same deal. The farther down you go, it probably gets a little darker and harder to see, which means if it's getting harder to see, the visibility might be going down, so maybe it'll be more negative. And all elementary school students, the weight and their score on a reading test, doesn't really matter whether you are an 800-pound first grader or an 80-pound first grader. More than likely, you can do whatever on the test. So the point is, as you look at this, the price for each t-shirt is probably explanatory. The number of t-shirts sold is probably the response, and the association would probably be negative. Because again, the higher out it goes, the price will, more people probably won't want it straight, and it'll probably be relatively moderate. There's no guarantee. There are people who have a ton of money, so maybe they, don't care about the price of shirts. But then, the same regard, people might view a shirt that's $2 and say, it's probably cheap. I don't want it anyway. The depth of water is probably explanatory in part B, and the water pressure in the response variable. The deeper you dive, the greater the water pressure. That's just how it works. So the association is positive because as we go deeper into the water, the pressure becomes more and more. So it's probably reasonably strong, right? It's not like, well, now I went down here, now the pressure went up. I would say that would be a little stronger, right? The depth doesn't change. It was the quantity of people who possibly want to buy a shirt. Doesn't matter what the price. They might or might not buy it either way. The pressure is pretty consistent, so it'll probably be strong with that one. Scuba diving depth versus visibility. All right, it's the same deal. Explanatory means visible. So explanatory is probably the water depth, and the visibility is the response. And the association is negative because it's probably harder to see the lower you get. And again, it says the association is negative. It's probably pretty close to straight, and moderate if a sample of different bodies of water is used. Now here's what you mean. It could vary. If we're talking about the same area, the same body of water, over and over again, you keep doing this, it kind of depends, is what it's saying. If the same body of water has visibility measured at different depths, the association might be strong. As in, if it's the same. If we were all going in like a bay, and the deeper you go, it's like, oh, I can't really see much anymore. That's what they mean. Is it the same per? And then part D, again, it appears that there should be no association between the weight of elementary school students and the score. However, with weight as the explanatory variable and score as a response variable, the association is positive, straight, and moderate. Students who weigh more are likely to do better on reading tests because of a lurking variable of age. It says all elementary school students weight, score on a reading test, right? There's probably no association. So, but there could be. It says certainly older students generally weigh more and generally are better readers. So what they're getting at is it depends on who's being pooled. Is there an association? No. But could someone argue a point that there is? And this is what we were talking about with lurking variables. And that's a lurking variable. It's kind of like, yeah, well, if we said no, great. But what about a sixth grader? A sixth grader probably can read better than a kindergartner. But if you're just putting all elementary school into one category, it might make it a little more difficult to figure this out, which is why they're going over the fact that there is a lurking variable here, right? You would assume that as the weight goes up, that they could read more in the case of just having a pool of all kids. Then those kids might be older or younger. But if we're only talking about like kindergartners only, does weight matter? Probably not, right? Do you follow what we're getting at there? All right, so we're just kind of looking over some of these. So when I come back, we'll take a look at some more. This is just some background, us figuring out these variables and how they work and what's explanatory versus response, just so we can go over it.